In this question, a scientist wants to generate the fictional compound T2 using the following reaction involving fictional elements with the symbols T and E at a temperature of 298 Kelvin. So here's our reaction. We've got 2Te3 goes to T2 plus 3E2. And the thing we're trying to produce is T2. So this is our goal product. Now, looking at our Gibbs free energy here, for this reaction, the change in Gibbs free energy is positive 208.3 kilojoules per mole. In other words, our delta G naught is greater than 0, meaning that we have an unfavorable forwards reaction. So we want to produce T2, which is one of our products. So we need to make the forwards reaction favorable. One way we can do this is to couple this reaction with another reaction that has a negative change in Gibbs free energy, so that when we add together the change in Gibbs free energy for both of the reactions, we end up with a negative number. That will mean that we end up making our reaction thermodynamically favorable. So we're going to look at these reactions listed down here in this table, and we're going to choose one that will make it thermodynamically favorable overall when we couple them together. Let's start by going through our reactions and figuring out which of these could pair with the reaction we've been given to produce a thermodynamically favorable reaction that has delta G naught less than 0. So let's look at this one first. In reaction 1, we're going to combine D, a new element that didn't appear so far in our reaction, with T2 that was produced here to produce DT2. So in order to do that, we've got one T2 in our reaction here. We've got one T2 in our reaction here. So we'd need one set of reaction 1 in order to pair with our goal reaction. So what Gibbs free energy would we end up with? So for this one, our given Gibbs free energy in the question is 208.3. Then we'd need to add our change in Gibbs free energy for reaction 1. We just need 1 mole of that reaction to pair with our given reaction. So it'll be 1 multiplied by our change in Gibbs free energy given here, which is negative 233.5. So putting that in our calculator, that gets us negative 25.2 for our change in Gibbs free energy. So that would make this a favorable reaction. However, the other question we need to ask is, does it produce our goal compound? So our goal compound in this question is T2. In reaction 1 in our table, the T2 gets used up as it gets made into DT2. So even though this reaction would be thermodynamically favorable, it doesn't produce our goal compound because it has to get used up in order to make this other compound in order to make it favorable. So no, it doesn't produce the goal compound. So even though this reaction would couple with our given reaction to make one that's thermodynamically favorable, it doesn't produce our goal compound, which is T2. Now let's look at reaction 2. In reaction 2, we're going to be using up the E2 from our reaction by reacting it with R to form Re. So if we look here, we produce 3 moles of E2 in our reaction here. But reaction 2 only has 1 mole of E2 used up. So we would need 3 moles of reaction 2 in order for this to couple perfectly together. So we would need 3 moles of this reaction. So what would our delta G naught be if we had 3 moles of this reaction coupled with our given reaction? So let's take our delta G naught of our given reaction, which is 208.3. And we're going to add 3 sets of the delta G naught for this reaction 2, which is negative 52.2. If we put that on our calculator, we get 51.7. So the delta G naught would be 51.7. That's greater than 0. That means our reaction is not thermodynamically favorable. So this isn't going to work because it's not thermodynamically favorable. However, this one would have produced our goal compound, T2, because it doesn't use up T2 in that reaction 2. It uses up the E2, which is the thing we're not trying to create. So it's good that it produces the right goal compound, but it's not a favorable reaction. Okay, let's look at reaction 3 now. Reaction 3 has 2x plus T2 producing 2xt. So it uses up the T2 from the question. In the question, we have 1 T2 produced, and in our reaction 3 here, we have 1 T2 used up. So we would only need 1 mole of this reaction. Let's figure out what our delta G naught would be. Delta G naught for our given reaction was 208.3. Then we're adding 1 of our change in Gibbs free energy for reaction 3, which is negative 247.3. So if we put that into our calculator, we get negative 39.0. So our delta G here is negative 39.0. That's less than 0. So this is a favorable coupled reaction. However, we need to look at, does it produce the goal? So our goal is to produce T2. Again, this reaction here actually uses up T2. So that doesn't produce our goal compound because it's going to get used up. So no, this does not produce our goal compound. Finally, let's look at reaction 4. We've got Z plus E2 gives ZE2. So in our given reaction, we produce 3E2. In this reaction, we use up 1E2. So we would need 3 moles of this reaction in order for it to couple perfectly together. Let's figure out what our delta G naught would be. The delta G naught for our given reaction is 208.3. Then we're adding 3 lots of the delta G naught for reaction 4, which is negative 76.0. Let's put that into our calculator. That gets us a delta G naught of negative 19.7. That is a negative number, which means delta G naught is less than 0, which means it is a favorable reaction. Lastly, we need to look, does it produce our goal? So our goal compound is T2. Reaction 4 uses up the E2 produced in our original equation. It doesn't use up the T2. That means our T2 will still be there. So yes, this produces our goal reaction. So when we're choosing which of these reactions will work to couple with our given reaction, produce our goal in a favorable way, reaction 1 is favorable, but it doesn't produce our goal. Reaction 2 produces our goal, but it's not favorable. Reaction 3 is favorable, but it doesn't produce our goal. Only reaction 4 is favorable and produces our goal compound, which is T2 in this question. So which reaction could be coupled? It's going to be reaction 4. How many moles of the reaction would we need to couple exactly with the original? We would need 3 moles. And what would the overall change in Gibbs free energy be for the pair of coupled reaction? It would be negative 19.7. So in this skill, you need to go through each of the reactions that are given to us and you need to figure out how many moles of those would we need to pair with our given reaction. When we add together the delta G of our given reaction with the required number of moles of the delta G of our paired reaction, do we end up with a delta G naught less than 0? If yes, that's great because that means we have a favorable reaction. However, it also needs to produce our goal. Whatever the goal compound is in this question must be produced, which means it's not going to get used up in our paired reaction.